Video, we're going to deal with solving quadratics by completing the square. And this method is used when you can't factor. So your goal here is to rewrite your formula or your equation so that you can extract the square root, which is what we did in the last video. So we're going to rewrite so you can extract the square root. So I'm just going to go right into an example, and then along the side, we're going to write down the steps. And hopefully that'll help clear it up on what we're going to do. First thing you need to do is make sure your leading coefficient is equal to 1. Which in this case it is. So we can move on to the next step, which is to move the constant to the other side. Okay, so I'm going to take -1 and subtract it so that I've got x squared plus 4x. And I'm going to leave a little space where I move that constant and move the -1 to the other side. Now, I'm going to look at my b and take half of b and square it, and then I'm going to add that to both sides. So let me write that down and then I'll show you what I mean. Take half of b, square it, and add to both sides. And the reason why I'm doing that is I'm trying to create a perfect square. So I'm going to take 4 divided by 2, which is half of b, and square it. Which here is nice. 4 divided by 2 is 2. Squared would be 4. So I'm going to add 4 to both sides. Now it's not always that nice, but take advantage of it when it is. So half of b, which is 4, and square it. And then add to both sides. So here I've got x squared plus 4x plus 4 equals 3. Now what I've done here is this has become a perfect square. If I factor that, it will always factor into x plus whatever half of b was squared. And then that equals 3. So the whole purpose of taking half of b and squaring it is to make a perfect square. So half of b was 2. That's always going to be what your linear factor factors into squared. And then once you have that, we can extract the square root like we did in the last section, which gives us x plus 2 equals plus or minus square root of 3. And then you're going to get x by itself by subtracting 2. So that means that x equals -2 plus or minus the square root of 3, or you can leave it plus or minus square root of 3 minus 2. It'll take either form. So that is extracting the square. Let's look at one more example. So here we've got 2x squared minus 5x minus 10 equals 0. Notice that your leading coefficient is not 1. So what we're going to do is we're going to divide everything by 2 to make a equal to 1. So that's going to give us x squared minus 5 half x minus 5 equals 0. Now this is where it gets a little tricky. But first, let's move our constant to the other side. So I've got x squared minus 5 halves x, leave a little space, and then your 5 on the other side. So here, I need to take half of b and square it. So b is 5 over 2, or negative 5 over 2. And I'm going to take half of that and square it. So let's work this out a little bit at a time. Negative 5 over 2. If you divide that by 2, that's the same thing as multiplying by 1/2, which would be negative 5/4. And then you're going to square that, which would give you 25 over 16. So I've got 25 over 16 is taking half of b and then squaring it. So that's what we're going to fill in here. We're going to add 25 over 16 to both sides. Now, I don't think I mentioned it in the last example, but the reason why you add it to both sides is because I'm keeping that equation balanced. I can't add something to one side and not add it to the other. So I'm trying to make a perfect square out of this side of the equation, but if I add 25/16, then I have to do it on the other side also. So here, that looks kind of ugly, but that has made a perfect square, which factors into x minus half of b, which was not that. It was 5 over 4 squared. So half of b was right here. That's what that is always going to use as our linear factor. And then that equals 5 plus 25 over 16. If you do a little math, if I want to say 5 over 1 plus 25 over 16, I've got to multiply this top and bottom by 16 to get a common denominator, which is going to give me 5 times 16 is 80 over 16 plus 25 over 16 will give me 105 over 16. And I did this by hand, but most of y'all have a calculator. The simple scientific calculators will add fractions for you also. So what I'm going to do here is I've got that from this. Let me erase this real quickly. So now I'm going to extract the square. I'm going to square root both sides. So I've got x minus 5 over 4 equals plus or minus the square root of 105 over 16. Now if you notice, 16 is a perfect square, so I can take the square root of that. I'm going to do a few things at the same time. I'm going to add 5/4 to both sides. So I've got x equals, I'm going to put it first, 5/4 plus or minus the square root of 105, and then the square root of 16 is 4. And 105, if you check the factor tree, will not simplify anymore. So that is your final answer. You get 5/4 plus or minus the square root of 105/4. So I think you might have one problem on completing the square in your homework. I probably will not put one of those on the test, but I just thought I'd show it to you so you know how you can complete the square. It's also what is used to derive the quadratic formula, which is what you will use a lot. So it's where the quadratic formula comes from. But I'll put that in the next video. We'll solve quadratics using the quadratic formula.